So, the very first thing we have to do always is make sure that our equations are in y equals, remember, transformation, and there's a what in front of the x? A positive what in front of the x, right? Now your format for equations is y equals a sine b x minus c plus d. Or cos. And those are the only formulas for chapter 5 that are at the bottom of your formula sheet. They have it showing the b pulled out, right? And then there's a 1 in front of the x. B, G, C, X out, and a 1 in front of the x on your formula sheet. So there's that. And the other one on the formula sheet is y equals a cos b x minus c plus d. So number 1, people get confused. They don't know if it's with the x or not with the x. If it's with the x, it would have to be what? In brackets. So what I get people doing on a test, do not do this, is they'll say, Mrs. Lepp, it's a horizontal phase shift 3 units left. And I'm like, it's not with the x. And they're like, I said, is there brackets? And they're like, yeah, there's brackets. And then I say, did you draw the brackets? And you go, yeah, I drew the brackets. So then I repeat myself, was there brackets? And you're like, well, now there's brackets. And I'm like, we just do a vicious circle. So there wasn't brackets. So if you so choose to write brackets around the x, it's literally just around the x. Because if there was brackets with the 3, there would have been brackets there, correct? So if there is no brackets, I would have you just put a bracket around the x so you try and not make that be horizontal. Okay? So, what transformation occurred? Yeah. Yes, vertical displacement. Units up. Now what I would have you do, which might help you out, is to have the graphs of sine x and cos x out from yesterday. So your basic sine x graph, your basic cos x graph from yesterday, because we're going to look at transformations to those functions, and we're going to see what would move, what would change. Okay? So that sine graph and cos graph from yesterday should be out. All right. Now, what kind of mapping is this? What mapping would we have? X, Y becomes what? Remember, mapping and words are in the same heart, so we use the same thing. X, comma, Y plus 3. If we're moving 3 up, we need to add 3 to 1. So, amplitude. Let's talk about our amplitude. Our amplitude is the vertical, half the vertical distance, correct? So what's the only thing that will change your amplitude? Yeah, vertical stretch. Vertical stretch will pull it to be taller or squish it to be shorter, correct? Will a reflection do anything to it? No, it'll flip it, but it's not going to make it taller or shorter. Moving it up or down, will that do anything to it? No, it will just move it up or down, but it's not going to make it taller or shorter, so that's the amplitude change. The amplitude is also off of here. Your amplitude, just a side note, your amplitude equals the absolute value of A. Paying attention, you guys can be lost. Absolute value of A, so in this case, it's the absolute value of 1. So it's 1. Did my amplitude change if my amplitude is 1? No, your basic function, your parent function of a sine graph or a cos graph has an amplitude of 1. So that means from the midline up, it's 1. From the midline down, it's 1, right? And so what's the height difference, the vertical height difference of the whole graph? 2, because it's twice that. Yeah? So did the amplitude change? We have to circle what changed. Did the amplitude change? Nope. Did the range change? It's normally from -1 to 1. I now moved it 3 up. So it's going to be from what? -1 to 1 moved 3 up. 2 to 4. Right? So my range is going to change. Is the period of the graph going to change? period is how long it takes to repeat itself horizontally, right? So that's 360 degrees, or 2 pi if it's in radians. What's the only thing that can change that period? Horizontal stretch. Making it take longer to repeat itself by making it wider, or squish it and make it repeat itself faster, right? The horizontal stretch would help with that. So the period doesn't. What about the domain? It's XER. Ooh, I went to circle it. Cross that up. So that isn't going to change because it's only y is happening here. Now some people will say, well, my x-intercept isn't going to change either because it's x and y plus 3, so it's only affecting y's. Would my x-intercept change if I take my x-intercepts and I move them up 3? It's going to take them right off, and I'm going to get new x-intercepts, won't I? So this changes. What about my y-intercept? My y-intercept of this one is at 0, 0, and now I'm going to move it 3 up. So what's it going to be at? 0, 3. Yeah. So it changes as well. Okay, how could we obtain the range of the graph? So this is what I'm going to help you with. So if we look at a graph, a sinusoidal graph, say this is my sinusoidal graph, it's a changed one. We're going to say it's like this. This isn't the graph that I'm giving you. So say my midline is at y equals 4. Right? Let's pretend it's at y equals 4. That's my midline. Amplitude, what's the definition of the amplitude? Half the, what's the definition of the amplitude? Half the vertical distance from the min to the max, correct? So the min to the max is 4, the amplitude is 2. If the min to the max is 9, the amplitude is 4.5, right? It's half of the vertical distance. So, if I take my amplitude and say I tell you my amplitude is 2, what's my maximum? 6. And I say my amplitude is 2, what's my minimum? 2. What did you do? You went midline plus amplitude to get the maximum, and then you do midline, subtract amplitude to get the minimum. Do we agree? So we're going to write that as a side note for ourselves. The maximum equals the midline plus the amplitude. You want to know something fun? The amplitude is the absolute value of A. We've discussed that, correct? Yeah? Normally our midline's at y equals 0. What's the only thing that can move our midline? If I stretch a y equals 0 line, does it get wider? No. If I reflect it, does it change it? It's the only thing that can move my y equals 0 line. The vertical displacement. So fun fact, D, this is the D. Remember it's A, B, C, D, right? The D is the midline. Because the only thing that can move that y equals 0 line is the vertical displacement. So the vertical displacement is the midline. There is no vertical displacement, which is sine x graph, the parent one that I gave you yesterday. There was no vertical displacement. It starts at y equals 0. The vertical displacement gets me my midline, right? So instead of saying midline plus amplitude, I could say D plus absolute value of A. And the way I remember it is das is good, like German. DA. Don't do AD, it will be wrong. A plus D will get you the maximum. Yep. A minus D will not get you the minimum. You'll be wrong. And do you think the answer will be there? Are you messing those two up? Yep, common error. Okay? Now some people are like, I can just go to my calculator and do left bound, right bound and get myself a min and a max. Yeah, you can unless your equation's in all variables. Then your calculator don't work. Right? So we need to know. So D plus amplitude, and then the minimum is midline minus amplitude, because if I take that middle line and I subtract off the amplitude, I'll get the minimum. So it's D minus the absolute value of A. Yeah? So remember the range of a sinusoidal function, the range is literally just y such that the minimum is less than or equal to y is less than or equal to the what? Max. YER. And the mins and maxes are really easy to find if you have A and D, correct? So how can the range be obtained without the graph, without looking at the graph? We need to get our min and our max, correct? So our minimum is the, so it's D. What's my D? What's my midline? 3. Plus my amplitude. What's my amplitude? 1. And I get 4. So my D is 3. My absolute value of A is 1. Correct? So I have a midline at 3. I have an amplitude of 1. That gets me to 4. We agree? I have a midline of 3. I have an amplitude of 1. Where does it get me to minimum? 2. Oh, I wrote the max. Why is no one... Your eyeballs were telling me something was wrong. You can either fix that or you can write max. Oops. Min is 3 minus 1, which is 2. That's you. So when I go do my range, I'm going to do y such that 2 is less than or equal to y is less than or equal to 4. Y is now in the zero. What's the period of this graph? Sorry? 360. Is there a horizontal stretch on this graph at all? Is there a B value? No, so it stays 360, right? Also, the period can be found by going 360 or 2 pi, depending on what it's in. It can go 360 degrees times the horizontal stretch, or you can do 360 degrees divided by B. Why can you divide by B? If B, say I have y equals sine 3x, what is my horizontal stretch? 1/3. So I'm multiplying by 1/3. We agree? Okay. If I divide by B, I'm going to divide by 3. What happens when I divide by 3? It's the same as multiplying by 1/3. So it doesn't matter which one you remember. You either multiply by the horizontal stretch, so that flips it, or you divide by B, which indirectly will flip it when you multiply. Okay? I always do the division of B, but if you want to remember, it's multiplying by horizontal stretch, same thing. So in this case, the period is just 360, because horizontal stretch and B are all 1. Okay. Does 2 change anything if it's a cos? A cos is just a 90-degree shift of a sine graph. So if you look at the sine graph and the cos graph, they're literally just a 90-degree shift of each other. So they're a horizontal phase shift. That's it. So is it going to change anything, the rules we just used to find all the things? If it's a cos? Nope. Let's try it out. So this one has, I'm going to put a bracket around my x. This one has a vertical displacement. Two units. Where? 2 units. Down. And to help myself out, I'll say it has an amplitude of the absolute value of A. My A is a 1. Remember, if A and B don't have any numbers, they're 1s. If C and D don't have any numbers, they're 0s. Because C is a horizontal translation or horizontal phase shift. It can be 0 or a number. Same with displacement. But stretch, they have to be at least 1. You can't have a stretch of 0. Then it would just completely kill your graph. So amplitude is the absolute value of 1. So it's 1. And what's my midline? should have actually wrote it as a line. What's my midline? Y equals what? -2. The only thing that can move that y equals 0 is your vertical displacement, which moved it 2 down, right? Your d is your midline. My mapping, xy becomes x minus 2. That's a lie. X comma y minus 2. And the same things will happen that happened here, right? Even if it's a coast graph. My amplitude doesn't change. My range does. Period doesn't. Domain doesn't. X-intercept do. Y-intercept does. All right. What is the range? Well, in order to get the range, I need my max and my min. So my maximum is d plus the amplitude. So it's going to be d, which is -2 plus amplitude, which is 1, so I get -1. And my minimum is d minus the amplitude. So it's going to be -2 minus 1, which is -3. And that makes sense. It's normally -1 to 1. It moves 2 down. So now it's going to be from 1, it's going to go to -1, and -1 is going to go to -3. Right? So my range is y such that -3 is less than or equal to y, less than or equal to -1. Y is now in the reals. And the period is 360 degrees divided by b. What is b? My b is always what's in front of my x. What's in front of my x? A 1. And did anything happen to it? Did it stretch it? No. 360 degrees. Try 3 and 4. So, what does the 3 do? Don't all speak at once. What is it? Yeah. Vertical stretch by a factor of what? A factor of 3 about the x-axis. So I know from my mapping, I'm going to have x, y become something 3y. Okay, and then what is this 2? Go away, little box. What's the 2? It's not with the x, because if I put brackets, x is like that. What is the 2? Vertical displacement. 2 units up. And x stays the same, correct? Amplitude is what? Is the absolute value of 3, which is 3. And then the midline, y equals what? Y equals 2. So technically I have a line at y equals 2, correct? And I go up 3. So I get a maximum of 5. And I go down 3. So I get a minimum of, oops, 3 is here, of -1. Right? You should be able to visualize it, not just memorize it. Okay. So did the amplitude change? It was 1. It is now 3. Did it change? Yes. Did the range change? It was from -1 to 1. Yes. Period? No, no horizontal stretch. Domain? Never going to change. X-intercept? Yeah. Because they are being moved up, down. Y-intercept, yes. Okay, so my range is going to be y such that -1 is less than or equal to y is less than or equal to 5. Y is now in the reals. And the period is 360 degrees. Or if I asked in radians, it would be 2 pi. Yes. What's the amplitude of this one? It's 2, because it's the absolute value of -2. Guys, why does an absolute value turn positive?
That's its job.
That's its job. What does the absolute value ask you for? The distance from 0. That's why I told it's positive. So how far is -2 from 0? 2. So that's why the absolute value signs always change something to positive, because the definition is, okay, absolute value -2, how else could I ask that? What is the distance that -2 is from 0? It's 2. That's why it turns into positive. Okay, and then my midline is y equals -3. So I have a midline at -3. And then I go up 2. So what's my max at? -1. And then I go down 2 from -3. What's my min at? -5. See how you can visualize it? Not memorize it? Understand it? So then we have a vertical stretch by a factor of 2, not -2, about the x-axis. What does the negative do? Reflection in the x-axis. And what does the -3 do? Vertical displacement 3 units down. All help change vertical things, so it's xy becomes x comma -2y minus 3. Did my amplitude change?
Yes.
Yeah, it's 2 now. Did my range change?
Yes.
Yeah, it's from -5 to -1. Did the period change? Domain. These two?
Yes.
My range is going to be y such that -5 is less than or equal to y, less than or equal to -1. Y is now in the reals. What's the period in radians? 2 pi, no stretch.